Hello, Afton. How is everybody doing today? Hopefully it's a good day for you. It's a good day here. It's always a good day anytime we talk about Pascal's triangle. Now, this is not a light blue, pink, or purple triangle. That would be a pastel triangle. This is Pascal. Pascal was a mathematician who, he did it. I guess he's kind of famous. But he came up with this thing, and this really interesting thing when you look at it. He came up with this thing called Pascal's triangle. So I just wanted to go ahead and kind of show you visually what Pascal's triangle looked like first, and then we'll kind of dive into some of the things that are kind of interesting about it. So what is Pascal's triangle? You see a bunch of numbers, and seemingly these look like random numbers. And I agree with that assessment 100%. This just looks like a bunch of random nonsense in all of this. But it's really not. If I were to go ahead and take any number here, okay, I'm just pointing to the 3, it is the sum of the 2 numbers that are above it. So 1 plus 2 gets me 3. And I can keep going right here. 3 plus 3 gets me 6 for 10, 4, and 6. That's how I got the 10. So this is actually an infinite triangle. This triangle can extend forever and ever and ever, and we'll just end up being the way it is. So notice that there's all these 1s on the outside. The way that we can think about that is, well, yeah, there'd be a 0 over here. So if I did 0 plus 1, that would give me a 1 right here. And then for the next number, 1 and 6, that gives me 7. 6 and 15 give me 21. 15 and 20 give me 35. 20 and 15, 35. 15 and 6 give me 21. 6 and 1 give me 7. And 1 on the outside. So we can see there's a row of Pascal's triangle. And again, I can keep going. If I want to make the next row or the next 20 rows, I can just keep going with this process. So now a few things to point out. That very top row, we consider that row 0. What I personally always say is the second number you see in the row, that's the row number. Well, there is no second number. Also, it's row 0. This is row 1, row 2, row 3, row 4, row 5, row 6, and row 7. Now, that's going to become important, this idea of a row number here in a second, but that's the same idea. That's just basically something I wanted to point out here, is that we have this row number. So Pascal came with this triangle, and then whenever Pascal himself or other mathematicians started to dive in and look at more things, there were a lot of cool things that we saw. So the first thing you might notice is that there is a line of symmetry here. If I were to go ahead and I were to just draw a line right where that 1 is, right on down, notice that everything on the left side has a mirror image with stuff on the right side. Now, there's even and odd numbers in each row, so when there's an even number, you can see, hey, look, that and that. When you see there's an odd number, there is a unique number in the center. So we can see 6, and we can see 20 right there, and then so on from there. So that's just kind of thing. Maybe you noticed that. Maybe you just kind of looked at that and noticed that right away. But then a few other people noticed some things as well. So there's the thing called the twos trick. There's a thing called the twos trick here. Or if I go ahead and I add up the numbers in this right here. So if I add this up, I end up with a 1 right there. If I add those up, I end up with a 2. I add those up, I get a 4. I add those up, I get an 8. I add these up, I get 16. Now, there is mathematical reasons for why these numbers end up being the way that they are, but what really is interesting is this is simply 2 to the 0 power. This is 2 to the first power. This is 2 to the second power. This is 2 to the third power. This is 2 to the fourth power. So the sum of the numbers in Pascal's triangle, the sum of these numbers is simply 2 to to the row number power. So this right here, I can tell you without even adding it up, which we could add it up if we wanted to, but if we add it up, I know this is going to be 32 because that's what 2 to the 5th is. So that's what we call the twos trick in here. The other interesting thing is that we can do the same thing with 11s where we're not adding them, but if we look at this guy, if we just look at this as just a number here. So this right here is just 1. That's 1, 1, so that's 11. That's 1, 2, 1, so that's 121. That's 1, 3, 3, 1, so 1,331. This is 1, 4, 6, 4, 1. Now, the kind of interesting thing is that that is 11 to the 0 power, 11 to the first power, 11 to the second power, 11 to the third power, 11 to the fourth power. Now, for this one, you might go, well, wait, hold on, there's some double-digit numbers here, Mr. Keith. Well, I can tell you that 11 to the 5th power is 161,051. And I go, wait, that's not what we see right here. Well, I take the 1, I take the 5. This is a double-digit number, so I actually just add that 1 to the next one. So that's where I got that 1 right here. Okay, I got the 0 from that right there. And then I have to add that 1 to the next one. I get 6, and then I get there. So this was a little bit of a stretch, but it is still a pretty cool thing that ends up happening here for the 11th trick. Now, again, I would be more hesitant to do this one, but again, still kind of cool. There's something called the hockey stick trick, where if I go ahead and if I were to just pick any one on the outside here. So if I just go here and I just draw a diagonal, so 1, 3, 6, and then I make a turn, I make a hockey stick. Then I can see if I add the numbers this way, 1 plus 3 plus 6, oh, hey, look, that gets me a 10. If I go ahead and I'll just go from here, 1 plus 4 is 5, 15, 35. This actually, I mean, other than a mathematical principle of kind of showing the idea of concurrent sums and things like that, this is just kind of a neat little thing that I always like looking at and showing. But now here's the thing. Let's get to the meat and potatoes. Let's get to the thing that I actually want to talk about today. Because you might be like, all right, those are all cool things, Mr. Keith. What does that have to do with college algebra? What is the hockey stick trick and the twos trick and the 11s trick, and what does all that have to do with college algebra? Well, those things, not so much. This thing, though, what I'm about to show, it's going to blow your mind. So I circled a 20. I circled a 20 here, seemingly randomly, but I circled a 20. Here's what I want you guys to do. At your desks, or tables, or wherever you're sitting. I don't know, the beach. You could be on the beach right now for all I care. At your cabanas. So I want you guys to go ahead and find the combination of 6. Choose, sorry, not 4. 6, choose 3. So what you guys get, go ahead, hit that pause button. Go ahead and try to find that there at your desk. Great, now that you're back, what'd you end up with? You got 20. Now, that could have just been some random coincidence. You know, I could have just said, hey, you know what? I was like, yeah, I knew that was 20, and I just picked some random numbers. All right. So at your desk, I want you guys to go ahead and find 7, choose 2. I want you to go ahead and find 7, choose 2. So again, hit that pause button. Great, now that you're back, what did you guys get? So you got 21. I'm going to write that. Every number in Pascal's triangle is a combination. That is the actual coolest thing about Pascal's triangle. All we did was say, yeah, I'm just going to add a bunch of numbers together and end up with these numbers. The coolest part of all of this is every single one of these is a combination. You're like, that's a combination? Yeah. That's the combination of 4 choose 2. That's a combination? Yeah. That's the combination of 5 choose 4. All of these numbers are combinations. So if I really wanted to, if I wanted to write out like 10 rows of Pascal's triangle, which we could do, I'm not going to make you, but we could write out a bunch of rows of Pascal's triangle and we could know a ton of combinations. We wouldn't have to do all the factorial stuff. Now, here's the thing. If I want to find, I don't know, 20 choose 7. If I want to find the combination 20 choose 7, well, I don't want to have to write out 20 rows of Pascal's triangle and then count to get where I want to get to. I was like, so the formula is still needed, but this can help us with some of those smaller combinations, and we'll see what we can do with it in just a second here. Now, a few things to point out. How did I know this number? Because if you look, you might be like, well, wait, Mr. Keith, that's the third number, which I agree, it is the third number. We have to remember, much like there is a row 0, there's a choose 0. So the row number is my top number. I'm in the 7th row. I can see my second number is 7. If this is 0, here's 1, here's 2. So that way when I say, I don't know, 4 choose 3. So again, I'll go to the 4 row, choose 0, choose 1, choose 2, choose 3. So we have to make sure we have this. Now, I tell students all the time, because students are like, can we have that for the test? You can always make Pascal's triangle. Okay? I mean, yeah, I know we're virtual and stuff like that. And again, if you have like a little cheat sheet next to you, I was like, am I going to be super upset about things? But I have Pascal's triangle, like up to a certain number of rows memorized. That's really how I have combinations memorized. But here's the thing. You never have to actually memorize Pascal's triangle. If you know, hey, this is 1, this is 1, this is 1, that's all you need. And then you can go, okay, yeah, that's a 1, that's a 2, that's a 1, that's a 1, that's a 3, that's a 3, that's a 1. That's a 1, that's a 4, that's a 6, that's a 4, that's a 1. You never have to memorize Pascal's triangle. Like I said, I do because I've taken a lot of math classes. I've done a lot of things with math. I do have Pascal's triangle memorized to a certain level, but this is pretty much where I have it memorized to. I know it out to 7. I know it out to row 7, I should say. So, but again, if I want to know the 8th one, yeah, just, okay, 1, 8, 28, 56, 70, 56, and then I really just a mirror image. So then I just flip those numbers. So again, you might be going, all right, well, kind of cool, I guess. Again, still, it's cool. How does that help us? Well, let's say I want to find a plus b to the 6th. So I go to the 6th row. That's a horrible looking arrow. What did I do? I'm going to say my board is not calibrated and I need to recalibrate the board. So I go to that. Now, I could sit there and I could say, okay, 6 choose 0, a to the 6 plus 6 choose 1, and then a to the 5th, b plus. I could keep going with that. I could write out all those combinations. Instead, I can just go, okay, cool. Here's all my initial coefficients. So with those being all my initial coefficients, I can just go ahead and say, okay, that's 1, which I'm not going to write the 1, a to the 6th plus 6, a to the 5th b plus 15, a to the 4th b squared plus 20, a to the 3rd b to the 3rd plus 15, a squared b to the 4th plus 6a b to the 5th plus b to the 6th. I'm done. Because of Pascal's triangle, I now know what all those coefficients are. So great. I was able to bypass needing to figure out. Now again, it's not, we've talked about that. Really, there only would have had to have been 2 combinations I needed to find because I already have these ones kind of memorized because they're simple formulas. But this saves me even having to do those 2 things. And those combinations are always the same. 6 choose 3 is always 20. So if I have Pascal's triangle, now I have a chart that basically tells me every single one of those combinations that I have memorized. So I don't have to go back and redo 6 factorial over 3 factorial, 3 factorial. I can look at Pascal's triangle and say, great, here it is, and be done. So with that exact same thing in mind, I can go ahead and I can say, all right, great. If I want to find x plus 4 to the 4th, I know that I'll start off with 1, 4, 6, 4, 1. Those are not spaced well. I'm going to space these all better. 4, 6, 4, 1. All right, that's a little bit better. Not much. I suck at spacing sometimes. All right. So now again, I can go ahead and say, all right, this is x to the 4th, x to the 3rd, x squared, x, nothing there at the end. And then 100. So times 4 to the 0, which I'm just going to write it for the sake of writing it, plus, and then this is 4 to the 1st, plus 4 to the 2nd, plus 4 to the 3rd, plus 4 to the 4th. Now, I do still need to do the math here, okay? On the previous one, because it was just A and B, that's why it was done. I didn't have to do anything else. So, but now look, I just got to do a little bit of multiplying. That's it. This isn't tough. In fact, this is pretty darn easy. So that's going to be x to the 4th plus, that's a 4, so 4 times 4 is 16, x to the 3rd. Let's see, 4 squared is 16. 16 times 6 is 96, x squared, plus 4 to the 3rd is 64 times 4. We end up with 256, plus 4 to the 4th. Oh, I forgot my x there, sorry. 256x, plus, and then 4 to the 4th is also 256. Again, I'm able to bypass those combinations strictly based on the idea of, hey, I know Pascal's triangle. And that is really cool. That's a really cool thing then. So, again, let's go again. Same idea. 2x minus 3 to the 5th power. Why don't you go ahead? Why don't you hit that pause button and go ahead and try this one on your own? You don't need me. As long as you got Pascal's triangle, you can come up with those combinations really quickly. So hit that pause button. Great. Now that you're back. So again, I'm going to start the same way. I know that this is 1, 5, 10, 10, 5, 1. Now, you might be thinking, well, while I was away, you went and looked at that, Mr. Keith. Well, again, I happen to have stuff memorized. But again, have this handy. That's fine. I mean, have this next to you while you're doing all these binomial problems. Again, I'm not going to be upset. If anything, I'm going to say, great. Like, you should get this done really, really quickly. Now I just have to go ahead and I'll say this is 2x to the 5th power, 2x to the 4th power, 2x to the 3rd power, 2x to the 2nd power, 2x to the 1st power. That one's going to need to move down a little bit. Then again, I won't have anything here. Now, I'm going to write this down just because I want to, I was like, I'm going to write this down in the first one here just to remind us. But this is -3 to the 0 power. If I remember, oh, this means alternating signs. I see there's a negative there. So because of that negative, I can go ahead and I can just say, okay, this is positive, negative, positive, negative, positive, negative. If I just want to go ahead and do that, now I can just go ahead and say, okay, this is 3 to the 1st, this is 3 to the 2nd, this is 3 to the 3rd, this is 3 to the 4th, and this is 3 to the 5th. Because I went ahead and I said, okay, I'm going to take care of the signs right away, I know that there's alternating signs. Really, I should have drawn. That's where the arrow should be. So, again, you can put the negative in there and then deal with it that way, but I think this is just easier. Now I just need to do this math. 2 to the 5th, that is 32. X to the 5th. Remember, the 2 has to be raised to the 5th power as well. Minus, I'll probably write this out. This is going to be 5 times 16 times 3. So that's going to end up being, let's see, that's 48. So 240. Yeah, that's right. 240 x to the 4th. Plus, this is going to be 10 times 8 times 9. So 720 x to the 3rd minus, and then that's going to be 10 times 4 times 27. So that's 108. So 1080 x squared plus 5 times 2 times 81. So that's going to be 810 x minus, and then 3 to the 5th is simply 243. No x. Again, Pascal's triangle just saves you needing to find all those combinations. But again, I think that's what makes these problems take the longest sometimes, is finding those combinations. So it's a really, really cool thing that we can use Pascal's triangle for. Now, because really this is just us building on top of what we've already done, I don't have a new assignment for you. I could have given you a new assignment. I just didn't feel like it. My suggestion to you, especially because, again, another short video, I was like, you guys got lucky 2 days in a row. I don't think that's going to happen. That is definitely not happening with some of the next things that we're going to be talking about. So I would suggest, hey, why not go back, take 1 or 2 of the problems that you had previously and just go ahead and try to see what you got here. So that's all I have. So on that note, I will bid you adieu. Until next time, stay safe out there, Afton.